And you add the exponents.
Bless you.
Meaning number 1 would be what? Right, Alex? Thank you. Number 2 would be what? Close.
Y to the 13th.
Y to the 13th, right, because we have to make sure we account for this exponent of 1. Even though it is just y, that is really y to the first power. And how about 3? Bryce?
A to the 3rd, B to the 3rd, C to the 6th.
Good job. So that is when we are multiplying the same bases. Today what we are going to do is we are going to divide this. It's not that hard. Okay. Dividing like bases. Now this says bigger power on top. We'll get to that in a minute. Okay? When you are dividing like bases, do you guys have a guess what you do with the exponents? You subtract them. That's exactly right. When you are dividing like bases, you keep the base.
So why is it called?
And you subtract the exponents. It says in parentheses, bigger power on top. Well, look at all of these, 4 through 7. The higher power is on top. What was another word that we used for the word exponent or power? What? No. We named it, starts with a D. We use constant, linear, quadratic, cubic, quartic, quintic. Naming polynomials by something and term. Degree. Yes, we can also talk about the exponent as the degree of a number. So, if you notice, we have all the bigger exponents on top. So, number 4, x to the 5th divided by x to the 3rd. Keep your base. X squared. You keep the base, then you just do 5 minus 3. It's 2. What's number 5? Good. Somebody raise your hand. What do you think for number 6, Jeremy? Very good. Because this is just like k to the first power. How about number 7? Nick, Alex? Yes, it's just x. Could I put x to the first? Sure. Do I have to? Nope. You could just leave it as x. Not really. Not quite. So we had all of our bigger powers on top. If I wanted to make any of these a fraction, so if I wanted to make x to the 6th a fraction, I can always put a number over what and it doesn't change its value. Over 1, right? If I really wanted to, I could put this over 1. Doesn't change its value. I could put this over 1. Doesn't change its value. Now, you don't need to, but I'm just pointing that out to you for our next slide. Dividing like bases, bigger power on the bottom. So we still keep the base. We subtract the exponents. But the variable stays in the denominator. So for example, number 8, x to the 6th divided by x to the 10th, your bigger number is in the denominator, your bigger variable. So you still just subtract them, 10 minus 6, but we have 1 over x to the 4th. So you still subtract them, but wherever the bigger exponent is where the variable stays.
Would that be a negative?
I'm sorry?
Would that be a negative 4?
Technically, yes. But until we get there, you're just going to subtract them, always make it positive, and put it wherever the bigger exponent is. But we'll get to your question in probably 2 days. So for number 9, your bigger exponent is in the denominator. That means that the variable is going to stay in the denominator. 5 minus 2 is 3. So y to the 3rd stays in the denominator because the bigger power is in the denominator. Can anybody do number 10 for me? Good. What about number 11? Very good. Now, if you have numbers, you still follow the rules of the exponents. So you follow the exponent rules. And you just do regular division with the numbers.
Tapping your finger.
Go on, Tyler. Just please stop. That's all. So for number 12, what's 3 divided by 6?
2.
No.
Negative 2.5. Negative 2.5.
Guys.
3.
Yes. 3 divided by 6 is 1/2, right? Just simplify that. That's just 1/2. You guys know that.
I do.
Oh, yes, you do. Now just use your exponent rules. X to the 4th, x squared. So you keep the base, subtract the exponents. Where does x squared go? In the numerator or the denominator? Numerator. Wherever the bigger power is where the variable stays. So I don't really need that 1 there. I'm just going to make that x squared over 2. What is 4 divided by 2? 2. Technically, that's the same as 2 over 1. If you want to write that 1 there, you can. You don't have to. Now we have y to the 7th and y to the 4th. Where is my y going to stay? In the numerator or the denominator? Numerator, right? And it's y to the 3rd. So do I even need that fraction bar there? No, because there's nothing in the denominator. Wherever the bigger exponent is where the variable stays. What's 3 over 5? Can you simplify that? 3 over 5? No, it just stays 3 over 5. What's k to the 4th over k to the 4th?
0.
It's nothing. Well, it's 1 technically, but they just cancel out. So we don't have any k's. We just have 3 over 5. What does 12 over 8 simplify to? Take out a common factor of both. Right. 4 goes into both of these. 4 goes into 12 3 times. 4 goes into 8 twice. Okay, now you've got x squared, x to the third. Your variable stays where the bigger exponent is. The bigger exponent is here in the denominator. 3 minus 2 is just 1, so it's just x. Okay, now this is more of the same. We just added in more variables. So do each variable separately. We've got y to the 5th over y squared. What does that leave me with? Y cubed. X to the 4th divided by x to the 3rd. 4 minus 3 is 1, so it's just x. Do I have anything in the denominator? Nope. So that's my final answer. Number 17. First, simplify 4 over 10. Someone raise your hand. Simplify 4 over 10. Jeremy. Right? Now I'm looking at the x's. Can somebody tell me what x divided by x squared simplifies to? Justin?
X.
In the numerator or denominator?
Denominator.
Good. Y to the 3rd divided by y. Very good. Anybody think they can do 18 for me? Alex? And? Right. That gives you 3. K to the 3rds cancel each other out. M to the 6th and m squared gives you m to the 4th in the numerator. For number 19, simplify 2 over 8, which is just 1 over 4. Make sure you account for that 1. Y to the 5th divided by y to the 8th. What is that? Y cubed in the, right? X squared divided by x to the 3rd is just x in the denominator. So this is just 1 over 4 y to the 3rd x.